Okay, this is the second video of 5.3. This time we're going to actually do some transformations to those parent functions of the square root and cube root. So we're going to describe the transformation, graph it, and state the domain and range. So our first problem, well actually I'm sorry, before we get started with the first problem, let's review our transformations. Okay, we had horizontal transformations, so that's moving left or right, which is along that x-axis. That's when it's in grouped with the x, so it'd be something like this, and it's the opposite of what it says. So if it says x minus 2, x goes minus to the left, but we do the opposite, so we're going to go right. Okay, then we have vertical translation, which is when it goes down or up. And that's just when a number is added or subtracted onto the end of the equation. That moves us up or down, and we do exactly what the sign says. Now, with reflection, we do not do a reflection in the y-axis. It flips over the x-axis. Oops, I should have left axis there. When it is negative out front. Okay, that negative reflects it in the x-axis, flips it upside down. Okay. We do not do a horizontal stretch or shrink. We do the vertical stretch or shrink. So that is when there is a number multiplying our radical. It may or may not have a negative with it, but the number itself determines the stretch or shrink. It is a stretch if A is greater than 1, and it is a shrink if A is less than, if 0 is less than A less than 1. Okay, those are the same rules we've had the entire time, every time we do transformations to one of our functions. So that's not going to change now that we're going to do it to radicals. Okay, so let's try it with the first one. Let's state what's happening. Okay, this minus 3 is grouped with x, so it's moving us left or right. In this case, it's a minus, and x goes minus to the left, but we do the opposite when it's grouped with x. So we're going to go to the right 3, so that's one of my transformations, is going right 3. And then on the end, I have tacked on this plus 4. That moves us up or down, and we do what the symbol says. So it's going to go up 4. So there's my two transformations that I'm going to have. So my graph, instead of starting at 0, 0, it's going to go right 3 and up 4. And then I'm going to use those points that we memorized with the parent function. Remember, now, this parent function is just a square root. Oops, square root of x. Okay, I can't square root negative numbers. But 0, 0, 1, 1, 4, 2, 9, 3. Again, if you have trouble going from the x to the y, figuring out what you can square root, you can always just start with numbers in the y value and square them. Do the opposite of square root. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Okay? Now, we're going to say this 0, 0 is this point right here. So from this point, I'm going to go right 1, up 1. From that point, I'm going to go right 4, up 2. Now that one's not going to fit on my graph. Okay, this one's kind of look like an eyebrow, a questioning, quizzical eyebrow. All right, so my domain on this one is when x is 3 and then it goes to the right forever. So x is greater than or equal to 3. Okay, in interval notation, it would have been 3 to infinity. The range is the y values, and y is up at 4, so it's y is greater than or equal to 4. And again, whoops, I can't write, I'm sorry. Interval notation would be 4 to infinity. All right, let's try that on number 4. This time I have a cube root, and it's got some things happening out front. Okay? That negative out front just means it is a reflection in the x-axis. This 2 is a stretch or shrink. It is greater than 1, so we have a vertical stretch by a factor of 2. It's whatever that number is. Nothing is grouped with x, so I'm not moving left or right. But tacked on to the end, I have a plus 1, so I need to move up 1. Okay, so those are all my transformations. The only transformation I'm worrying about is just put that little starting point is the up 1. Okay, you use the translations to find that. So I'm going to go up 1 and put my starting point. So if I write down the points that I had when I had a cube root of x, okay, it was -8, -2, -1, -1, 0, 0, 1, 1, and 8, and 2. But I have a value out front that is something other than 1. I have this -2 out front. So I need to multiply all the y values times -2. So that makes that a -4. Oh, I'm sorry, a +4. That makes that a +1. 0 times -2 is 0. 1 times -2 is -2. 2 times -2 is -4. So these are the points that I will plot. I'm going to go from this starting point. I go left, because I go -8, and then up 4. So left 8, up 4. Left 1 from that point, up 1. This is my 0, 0, is the point I put there. Then right 1, down 2. Up. This was a 2. I am sorry. So this point is actually right there. Ignore that one. Okay. And then we go right 8, down 4. And then when we graph it, it comes through and looks like this. So it is reflected. It's upside down. Flipped over that x-axis. It had a stretch, so it got a little taller. And it moved from 0, 0 up 1. Okay, so my domain is all real numbers, and I'm just going to abbreviate with the symbol, or if you wrote it in interval notation, -infinity to infinity. And the range is also all real numbers, goes up and down forever, and interval notation is -infinity to infinity. Okay, so now you can go to your practice and do problems number, let's see. Sorry, let me write it down for you. So go and do practice numbers 9, 14, 16, 17, 27, 35, 36, and 37. And then continue on with the next video.